In this lecture, we will learn about analyzing algorithms and finding their running time or complexity. Okay, so we will learn about an algorithm that is insertion sort, and it's quite good algorithm for analyzing its performance, and we will try to analyze its worst case and its best case. Okay, so this algorithm we will look at, and by analyzing this algorithm we will learn about the trade or the business of understanding analyzing algorithms. Okay, so insertion sort. So let's try to review this algorithm, insertion sort. So what happens in insertion sort is that we are given an array of numbers, n numbers are there, and what we do, so we try to sort the sequence and increasing one at a time. So we will see with one example. So let's say that we have an array consisting of 8 numbers. So what happens is it's 3, 5, 1, 2, 8, 6, 7, 10. Okay, so we have n is equal to 8 numbers are there. So we start from j is equal to 2 to n. So what we do, so an array of size 1 is already sorted. So what we do is that if given an array of from 1 to j minus 1, so what we try is now we have to place aj in this sorted array of a1 to j minus 1. Okay, so we try to put aj in its proper position in a sorted array a1 to j minus 1. So a sequence of length 1 is sorted already, so we start with 2, and then what we do, we see 5. Okay, so now 5 is greater than 3, so we will just put 5 at its second place. So it's fine when it's at original place. So when now we have this part is now of length 2 and it's already sorted, now we have to place 1 in this already sorted array. So we see that 1, so 1 we compare with 5 and we find that okay, 5 should be greater than 1, so it should be on the right side of 1. Then we compare it with 3 and then we find that okay, 3 should also be on the right of 1. So what we do, we shift these two numbers right and then put 1 in the empty slot. So that's what we did. We shifted 5 and then we shifted 3 and placed 1 here. Okay, so that's what we did. So now we have an array of 1, 3 and 5. So this is already sorted array. Now this part is sorted, and in this what we need to do, so we need to put 2 in this already sorted array of length 3. So what we do is now we compare, this is the jth slot, so we compare with j minus 1, and now 5 is greater than 2, so 5 will now be shifted once. We compare it with 3, 3 is also greater than 2, so we shift 3 here, and an empty slot is created here, so we place 2 in the second spot. Okay, so we have now a sorted array of length 4. Okay, so length 4 sorted array in which I have to now place 8. Okay, so now what we see, that 8 we compare with already sorted array of length 4 and we try to put the fifth element. Okay, so now 8 is greater than 5, so it should be on the right. So in this iteration I don't need to move any element. Okay, so now I have this length of array is sorted, and now I have 6. So we see again that okay, 6 is less than 8, so 8 should move to the right. 5 is not greater than 6, so 6 will come here and 8 just move towards the right. So this way if you keep on doing, so for 7 also, 8 is greater than 7, so 8 moves here and 7 comes here. So this is already sorted, so now 10 is greater than 8, so it's sorted. Okay, so this way we sort. So we see this in this algorithm form, it has the form for j is 2 to n. So we put key is equal to aj, that is the new element we want to put in the already sorted array of size a1 to j minus 1. So what we do, we store the key is equal to aj and I is equal to j minus 1. So from the j minus 1th element we start to compare it with the key aj. Okay, So till I is greater than 0, that is till we come to the leftmost part of the array, and till ai is greater than key. So what we do, ai plus 1 is ai, which means we are shifting it the number to the right so that empty slot is created to place the key element. Okay, and then we do I is equal to I minus 1. So this way we keep on doing for the jth element, to put the jth element in the sorted array of a1 to j. And now we want to analyze this. Okay, we want to analyze this algorithm. So what we see, for each line we will see how many times it was executed. Okay, so we will see here that, okay, the first line is executed, so it's executed n times. Okay, so because it's a for loop and it's running from 2 to n. Okay, so it runs for n times from 2, 3, 4, 5 till n. Okay, so and then what happens, key is equal to aj, so that runs for n minus 1 times. Okay, so this runs n minus 1 times, and then what happens is this one is, so this line is now I is j minus 1. Okay, so this is also because it is in the for loop. Inside the for loop it is executed n minus 1 times, and then what happens, we again have a while loop here. Okay, so in this while loop, so what happens, that we say that, okay, in the jth iteration when j is some value, so let us say that, okay, so it is executed tj times. Okay, this one, and tj is what, how many shifts take place. So what happens is j is equal to 2 to n, so we sum this up because the for loop is running from j is equal to 2 to n. So these many times this will run, and every time let's say that this line runs tj times. So this summation is the thing for the number of times in overall it runs in the for loop. And similarly ai plus 1 is equal to ai, the number of shifts in the j for j is jth iteration, and I is I minus 1. Okay, so if this is the while loop runs one more time, so they run tj minus 1 times. Okay, so this also runs tj minus 1 times, this step 7, and this step 6 also runs tj minus 1 time. And then what happens, we come out of the while loop and this runs for n minus 1 times. So here tj means actually, so tj is, so for, let's say for here when we were doing, so when the array was 1, 3 and 5 and we had to insert 2, so tj here means in this third iteration, so 5 moved towards the right, 3 was also greater than 2, so it moves towards the right, so j is equal to 2 here for, so number tj is equal to 2. Okay, when we had to make 2 shifts, so tj is equal to the number of shifts in the jth iteration. So number of shifts in the jth iteration, so that is what, and so we sum it for j is equal to 2 to n. So if we sum up, so let's now see the best case. So in best case what happens, the best case is here when this tj runs for the minimum number of times. So when tj is minimum, so this sum will be minimum. So now let's see, so tj will be minimum when it is already sorted. When the input that was given is already sorted, then tj will be 0. So let's see that example. So if 1, 2, 3, 5, so it is already sorted and now we have got the input 8. So 8 is already in its correct position. So now what happens, 8 is greater than 5, so it doesn't have to make any shift here. So we don't have to move anything, and so tj is equal to 0 here. Okay, so we don't have to do any work if it is already sorted, and hence tj is equal to 0 in the best case. Okay, so what happens now, first line is executed some n times, and because the coefficient we put so that it can take care of all the in the line what operations I have to take, then c2 n minus 1 plus c4 n minus 1 c5 n minus 1. So this way we add and we see that, okay, our algorithm is linear in n, so it is O of n. The second case is we consider is the worst case. So in the worst case, what can happen is the input is sorted in the reverse order. So let's say if we wanted to put it in ascending order, so the input is sorted in the descending order. So in that case, what happens? So what happens is that if it is in the descending order, so let's say it was something like, so the case was like if we have 1 3 5 and the worst case will happen, so it's 2 3 5, this is already sorted, and then we get 1. So now what happens here, it becomes like, so 1, now 5 is greater than 1, so this has to shift, 3 is greater than 1, so it has to shift, and 2 is greater than 1, so it has to shift. So for Tj will be equal to now j. Okay, so those many shifts we have to make. Okay, so for it was 3, then we had to make 3 shifts. So this way what happens now? So Tj is equal to j for j is equal to 2, 3 till n. So now our summation Tn is the summation of all the number of times each line of the code runs. So it is C1n plus C2n minus 1. C4 is the fourth line, it is executed n minus 1 times. Let's see C5. So C5 is this while loop, so it will be executed j is equal to 2 to n tj times. Okay, so tj is equal to j, so it is executed from j is equal to 2 to n and j. So this we know that summation is equal to, for summation of 1 to n is n into n plus 1 by 2, but as we are not summing 1, so minus 1 we do, and this is n square plus n minus 2, so n square minus n by 2, so this is n minus 1 by 2. Okay, so similar things we see there for summation here of tj minus 1 and summation for these two lines we see. So these also are executed this times, and we see that the highest term is n square in these. So we find that insertion sort becomes O of n square in the worst case. So this was about calculating the best case and worst case analysis for insertion sort. So I hope you understand this, and thanks a lot.